Okay. So we're going to solve for this problem here where we're looking at the code book, tables, articles that we need to solve for the piping and wiring needed for a 15 horsepower motor running on 575, a service factor of 1.1, which will be used for the overload relay. So the first thing we have to do is go to table 44. So table 44 is for a three-phase motor. It'll give you the nominal amps. First thing actually I want to mention is that if you have the motor on the job site, you always use the nameplate. Okay. Only when the motor is not installed yet, it's not on the job site, will you use table 44, or for single phase motors, table 45, or for DC motors, table D2. So here we have 15 horsepower, and just going to encircle 15 horsepower. We'll go down to here, and we have 575 volts. So 575. So this column here, this row here gives us 17 amps. So here's step number one. I'll write down the table number. We're looking at table 44. And as we just saw, it's 17 amps. Okay, for a 15 horsepower, 575 three-phase motor, as it indicates right here. Time delay fuse, that's still D16. So we'll go to D16. We'll look for 17 amps. 17 amps is right here. So we started off with DC motors where we looked at these three columns here, depending on what type of overcurrent protection we'd have: circuit breaker, time delay, non-time delay fuse. Now, for single phase AC motors, we use this column here. For three phase, we're also using this column here. Why? Because this has all types and squirrel cage and synchronous full voltage resistor and reactor starting. This section here is for squirrel cage and synchronous using auto transformers, one of the reduced voltage starters that we learned about, and star delta. Okay? So per phase, this is what we're looking at. So if we're looking at 17 amps, generally for motors, we use a time delay fuse. If you look at the multipliers here, look at the huge difference of the overcurrent protection depending on what you use. If you use a one-time fuse, which is a non-time delay fuse, you need a 50 amp. Why do you have to go that high? Just because it's 17? Because on startup, the motor draws typically 6 times nominal. And if you have a fuse, a one-time fuse less than 50, chances are it would burn when it start up, okay, or would blow. So time delay fuse, this is 25 amps. So this is what we're using here. For a circuit breaker, it would be 40 amps. These multipliers are found in table 29, and it's 175% the nominal for time delay fuse. So we've got 25 amp, a 25 amp fuse. So the disconnect switch. The disconnect switch will be based on the fuse size. I'll go back and show you the table right over here. For a motor, it'll always be an H for heavy duty. Now we have 3 phases or a 3-phase motor, therefore we need a 3-pole disconnect switch. 600 volt rating, so we have a 3 here, we have a 6 here, and we had 20 some odd amps or 25 amp fuse, which means we need a 30 amp disconnect switch. 30 amp, which leaves us a 1, and there's no neutral. For 3-phase motors, there are no neutrals. The only time we need a disconnect switch with 3 phases on 600 volts is if you're doing heating or lighting. That requires 347. So each phase with a neutral will give you 347. Okay, so we have an H361. H361. Wire gauge. So wire gauge, we're looking at nominal times 1.25. So nominal is 17 amps multiplied by 1.25. So that's our, this 1.25 is our safety factor, not service factor. This service factor here is for the OL. Safety factor is not to overheat the wire. It's the 80% rule. So you multiply by 1.25. So if we take the 17 multiplied by 1.25 is equal to 21.25. So 21.25 amps. With this number, we go to table 2, and we'll see that anything above 20, well, not anything above 20, but above 20, below 30, we're going to need a 30 amp. So we're going to go to table 2. So table 2, remember the Quebec amendments on this. So the Canadian electrical code, this changed for the last code book, but Quebec reverted back to the way it was before. So whether it's 60 degrees, 75 degrees, 90 degrees for 14, 12, and 10, they stay basically the way they've been for the last 3 decades. So we're looking at 21.25, 21.25. We're looking at number 12 is too small, so a number 10. So we need a number 10 gauge. And remember, this number here is going to be used to select our bonding. Okay. So wire size in millimeters squared. So we want to know that the area that a number 10 takes up. So we're looking at table number 10A. Number 10 is right here. We're looking at area. So this column here, 1567. So table 10A, a number 10 wire is 15.67. The total, well, you take the 1567 and you multiply by 3 because we have 3 conductors. So 1567 times 3 is 4701 millimeters squared. EMT. So in order to do that, we have to go to table 8 first. You can also use table 6 for this, but since we went through all the trouble of going through table 10 and finding out the size, we'll go to table 8 for percentage fill. Percentage fill right here. Table 8, we have 3 conductors. 3 conductors are percentage fill is for 40%. And this pipe here between the disconnect and the starter, this guy right here, this is EMT. Okay. This pipe here going to the motor, because it's the motor and it vibrates, this guy here is seal tight. Okay. So in this new code book, there's multiple table lines depending on the type of piping. So this is your EMT. So this is what we're looking right now. And we're choosing the 40% column. And we're looking at 4701. So basically our smallest pipe, which is 16 millimeters or ½ inch, will suffice. So table 9I is equal to ½ inch pipe. Okay, so you run a ½ inch pipe from your main source to the motor starter. The overload relay. So the overload relay is basically your nominal, and we'll look at that article again today, times the service factor, depending what the service factor is. If the service factor is less than 1.15, you multiply by 1.15. If the service factor is 1.15 and above, you multiply by 1.25. So in this case here, you multiply by 1.15. So if I take the 17 amps, multiply by 1.15, you get 1955. And this 1955 is approximately what you would set your OL to on the dial. So I'm just going to write down the dial on the OL. Sometimes the actual OL is already compensated for that 1.15 or 1.25, and they have a little label. So you basically would put it on the nominal amps. Contactor size. So this is also based on nominal. So we'll go to the table on the last page. So we're looking at was 17 amps. Actually, let me just double check that. Nominal 17 amps. So 17 amps with a NEMA 0, we can go all the way to 18. So it's a NEMA 0. So that's basically the contactor size, the size of the contacts for the contactor. Bonding, we said that the bonding was basically going to be based on the current carrying conductor, which is a number 10. That's on table 16. So table 16A, we're looking at a conductor, current carrying conductor, which is a number 10. So if we look at number 10 here, our ground will be a number 12. We want to know the size of a number 12, or the area. So number 12 is 1161. Millimeters squared. And we're going to add them all up. So we're going to add the 4701 plus 1161. So 11.61 plus 47.01, 58.62. 58.62 millimeter square. And now the size of the flex pipe going to your motor. Again, table 8 for percentage fill, but we know it's going to be 40% above 3 conductors. And then instead of table 9I, we go to table 9G for seal tight. Okay, seal tight, liquid tight, same thing. And we're looking at the 40% column. And we've got 47. Well, we're comparing the 58.62. So we go down to 78, which is a 16 millimeter again, which is a half-inch seal tight. So for seal tight, just a reminder, the smallest size, unlike EMT, is not half-inch. The smallest size is 3/8. They do not make EMT 3/8. Minimum size is half-inch. But in this case here, the seal tight is half-inch as well.